Good morning, everyone in the room and the folks on the live stream. George Howard here with some of my favorite friends in the world from the Comet Research Group, with the exception, technically, of Dr. Collins, who's joining us as a scientist and a scholar. And, I mean, you are not, I mean, it's a loose assemblage, the Comet Research Group, but you do not claim membership, right? Okay, you're ex officio. Okay. I just didn't want you to get tagged with it in case you want to. Yeah. That's right, but I didn't want to introduce you for something that you're not on the website and that kind of stuff for, because it may cause you problems. But the old Comet Research Group, a term you all may have heard, we originally called it the Younger Dryas Boundary Team, started in 2007 and rebranded it about, 2014 or so. But it is a loose assemblage of brave scientists, because it takes bravery to delve into these matters and even present hard data, because it's always greeted with skepticism by the others in their discipline, but they won't read the papers. It's just greeted with skepticism. It's not investigated. It's not followed up on. Yeah, if it was only skepticism, yeah, that'd be a step up from what we take. But there's an interesting phenomenon with the Comet Research Group, is that if you go and look at their work and agree with them, it doesn't provide them support. It labels you as one of the nuts, right? So the trick is just to get as many nuts together that are well credentialed, and now we've got close to 100 around the world, where you can tell that it's drawing people in because of the quality of the data and the quality of the theory and hypothesis. If you wonder what Younger Dryas Impact Hypothesis means, and it really could be called a theory now, and I'd like to hear from some of y'all on that if you have any scientific philosophical interpretations of when you go from hypothesis to theory, because I think we're there. It was originally published in 2007. Gunther, you were on that paper, right? No, you weren't. Okay, so I'm the only original author. I got a senior man on the stage here, the uncredentialed senior man. But I was really fortunate to join kind of as an enthusiastic amateur, and I have described myself as kind of the ball boy of the team, where you've got a team of really good players who can play the game, but there's always one kid on the bus who knows all the stats, knows where the bodies are buried, and the team likes him just because, he's always on the bus and hanging around. That's me, right? But like I say, over the years, it's drawn people in. Mark Young, when did you come in, Mark? I guess, 2021, after being an enthusiast himself over in Australia. Gunther, probably been around about 10 years. Malcolm, a little bit more than 10. Malcolm was a great example. He did an independent analysis in 2012 of our proxy data and said, is this really there? And had the necessary technical skills. I'd like him to describe them. But he came in as an independent, I wouldn't call it a skeptic, but just an independent Okay, would you? Yeah. And unfortunately, folks, we're stuck with one mic, which is a little bit of a surprise, but we're going to work around it. But remember, we have live streamers that will not be able to hear us unless we're speaking in the mic, and that's going to frustrate them, and there's going to be some of that, but let's try to minimize it for them. So Malcolm was a great example of someone who said, hey, let me take a look at this, some pretty bold claims. Let me see if I can back them up. And then he did. Then he called a bunch of shit, and he said, okay, well, I'll just join them. Is that accurate? That's right. And Joanne actually got her PhD with the Younger Dryas Impact Hypothesis in mind and built it around it, correct? Yeah, that's right. And Dr. Collins was the director of the dig at Tal El-Hammam that located Sodom, in my humble opinion, and many others, and is currently the most read scientific paper in the world of the last 5 years. It made Final Jeopardy. I'll never forget, one day I get an email that says, thing made Final Jeopardy, and the question was, what biblical city was discovered by a research team in 2021 in the Jordan Valley? Ding dong, ding dong, ding. And some guy won 20 grand because he knew it was Sodom. And I thought, if you've made it into Jeopardy, you've pierced the cultural veil. It really is. That and Joe Rogan. I mean, we got the dual endorsements there. But what I'd like to do is to turn it over to each of these and just give us your credentials, if you will, your background, and kind of your origin story, just a bit of it, and then we'll go a little bit deeper, your origin story for being a part of the Comet Research Group, and then we're going to start telling the story of the Comet Research Group as we have seen it and experienced over time. I'd like to start with Mark Young.
Yeah, hi. So I'm Mark Young. I joined the Comet Research Group after completing my bachelor's degrees in archaeology and environmental science. What actually inspired me to enroll at university was the Joe Rogan podcast with Randall and Graham. So I watched that, and then I went on a deep dive into Randall's Cosmography 101 classes on YouTube. And I'm absolutely hooked. Where can I go to study this? And I enrolled in archaeology at Flinders, and then transferred into the double degree. And then I did my honors degree, and then I got into the PhD. And I joined the Comet Research Group in 2021. I first got in contact with George in about 2018, I reckon. And we started working on the comprehensive bibliography together. And yeah, just from there, I was in more and more contact with members. And
tell them what you do with Comet Research Group. What has been your roles?
Yeah, so I've done a bit of lab work, working on thin sections, looking for shot quartz candidates. I've done some sedimentology work. I separated carbon spherules and glass-like carbon for carbon dating at a few sites. So I've done a little bit of modeling work with Alan West as well. So yeah.
For people that, like, I've got a couple of friends of mine from out of town who don't pay much attention to this stuff. Tell them what thin sections and shocked quartz are.
Sure. So thin sections are essentially you take some sediment, I suppose you resonate it, impregnate it with resin, and then you mount it on a glass slide, and you
take a slice, a paper thin slice.
You take a paper thin slice of that block, and you mount it on a glass slide, and you look at it under a microscope, and you can see through the grains using the microscope, so you can see the internal structures and all that. And shot quartz is what happens when large pressures are applied to quartz grains. Traditional shot quartz, they fracture along the crystal lattice, and you've got planar deformation features all the way through. I can probably pull up a slide.
While you're doing that, hand it on to Gunther. Let's hear Gunther's story. Mark.
Hi everyone, I'm Ginter Kletečka. I'm originally from Czech Republic, so Bohemia or Prague. And then I did my degree in University of Minnesota. Then I ended up at Goddard Space Flight Center for 13 years. Then I kind of went back and forth between Prague, Czech Republic, and Alaska Fairbanks. And I think the main reason for being here was 2008 expedition to Tunguska, where there was a Discovery Channel that was taking 3 scientists, including me, Mark Boslow, and one more person who were interviewed, trying to figure out what's the meaning of Tunguska impact. And since the Comet Research Group is interested in this phenomena that are triggered by airbursts, it make a direct link between the Tunguska and all these phenomena that the Comet Research Group is studying. And so I'm excited to compare the data we have from lakes in Tunguska, from the trees, and to compare them with much older data from Tal El-Hammam or with the samples from all over the world from the lakes during the Younger Dryas.
Dr. LeCompton, I will tell you this. Malcolm is actually a rocket scientist. You know, when people say, ha, 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 I'm no rocket scientist, he is one. Okay, go ahead. Take it away, Malcolm.
Yeah, that's how I started.
Yeah.
Yeah, I'm a planetary astrophysicist, and I got sucked into this by that interest. Is that I had a long-standing interest in impacts on the Earth. My background is a PhD in planetary astrophysics from University of Colorado Laboratory for Atmospheric and Space Physics, and my interest in the impacts goes back even before that. And I started doing my own work and realizing that the rate of impacts, not necessarily crater-forming impacts, but airbursts, just the rate of kind of the bombardment of Earth by Earth's extraterrestrial debris was much higher than was being touted in the literature. And taking that, I started, through Dallas Abbott's efforts, contacting the what is now the Comet Research Group, Alan West and Rick Firestone, and they kind of said, well, do you want to do this? Do the independent study? Because I said, I'm interested in doing some of the analysis to see if this is real. And I collected some samples, they collected or had collected other samples that I was sent. And I think we had, just from that study, we had 3 different sites. We had Topper, Blackwater Draw, and which is the Clovis name site, I believe, near Clovis, New Mexico.
These are archaeological sites that have well-dated soils where previous researchers have published paper after paper discussing the archaeology with nothing to do with catastrophe. But the Comet Research Group's original hack, if you will, was to say, well, we don't want to have to argue about dating where we find the proxies. We want to go to places that for 50, 60 years in some cases, you know exactly the timeline, the age and the depth of that site. And if we located anything or not, you could say what the age was without having to pay for all the dating.
With some confidence. On the other hand, we didn't realize how contentious the archaeological community is, because they've disputed the dating themselves, so that they've kind of backed off on their own dates to discredit the work we've done. So it's kind of an interesting conundrum that, we sampled the Clovis layer. Oh no, that's not the Clovis layer. Well, it used to be.
Yeah, until we came along. And we need to talk about sun algal at some point too. That's an interesting development.
We're rebutting.
Okay, and Joanne. Dr. Joanne Ballard.
So I met Rick Firestone, the lead author, in 2005 at a World of Elephants conference in Hot Springs, South Dakota, and it was just fascinating what he presented about the black mat and all the things he found, and I thought, well, I'd sure like to study that. So I was, at that time, a student at Indiana University Southeast studying geosciences. So then I went on to be a graduate student at the University of Cincinnati under Tom Lowell, a glaciologist, and he suggested, he'd attended one of their conferences, later conferences, where they rolled out that 2007 paper, and so he was somewhat skeptical of it, but interested in it. So he advised me to maybe I could look for evidence of fire in lake sediment cores, because that's the method he uses. So I developed a methodology to look for charcoal in cores that I took from close to Flint, Michigan. We cored 4 lakes in 2 days, and so I got charcoal data from all of those cores, which went back maybe 17,000 years. So he said, try and predict what you're going to find in the data when you do that. And so, you could have like nothing, maybe no charcoal, maybe you're going to have a spike at the Younger Dryas, maybe you're going to have multiple spikes. So it turned out there were spikes there, but there was also additional spikes. So in order to establish that you've got a fireball, you're going to have to put something else with that charcoal data, such as platinum or an erosional event or something of that sort. So I got my degree there in 2009 from University of Cincinnati, then worked at the Census Bureau for several years. Then I went to University of Tennessee to continue the research using lake sediment cores to try and further the cause of the Younger Dryas Impact Hypothesis, because that's what I'm really interested in. I'm a catastrophist. I think that's more interesting.
A little closer to the mic.
I'm a catastrophist. I think that's more interesting to study that than, things that happen slowly. And so I finished up there in 2015, and one of the things I found in lake sediments that was different as a fire proxy were siliceous aggregates which form from wood ash. So when a forest burns, the trees are storehouses of calcium, and so when it burns, that wood ash is calcium carbonate. The tree contains these little silica phytoliths that are then there in the wood ash. Then when the ash gets wet, it's highly alkaline, and the silica, the phytoliths, will turn to a gel. It would dissolve into a gel, and then if there's any silt or other particles in with the ash, it will stick to those, and we found those later as siliceous aggregates. They harden up, and so that's additional evidence. And in the
Some of those take the form, it's almost like a little fossil of what the plant looked like, right?
not exactly.
Or is that phytoliths only?
That's phytoliths.
Okay.
So the siliceous aggregates are going to contain silt-sized grains of maybe quartz, and then the amorphous silica. Sometimes there's organic inclusion, seeds or whatnot. So these mostly occurred at around the lake glacial. So we have a hard time constraining some of the ages in those southeastern lakes. But overall, it looks like a lake glacial signal, maybe a YDB signal of a catastrophic fire. And so additional work needs to be done on other lakes to see if that continues, if we find that signal in other lakes.
Where were the lakes that you found the signal?
So Cahaba Pond, Alabama, Anderson Pond, Tennessee, Jackson Pond, Kentucky, and 2 of the 4 lakes in Michigan. We only sampled 2.
Now, there are lakes all over the place. What's special about these lakes? Why do they tell you what happened 13,000 years ago? How does a lake tell you that?
So we don't want to take soil cores ideally, because that's a dynamic environment. You've got worms, you've got roots, you've got other things happening, animals burrowing. And so we consider lakes to be a more stable repository of sediments and what's going on in the environment. It collects the pollen deposits there, macrofossils from the trees around it, maybe mites and other chironomids, gnats, and so forth that paleoenvironmentalists will use to interpret precipitation and temperature and so forth. So my focus was on the charcoal, but I also used other people's pollen data. So that's, and in particular, the lakes in Michigan, I chose those sites because they were close to the Gainey site, which was one of the main sites that Firestone and West and Topper at that time pointed to as evidence of the Younger Dryas impact. So I thought, if I'm going to plan my research project, I should go to one of their sites, which is a huge archaeological site. There was a lot of stone tools found near those 2 lakes, Slack and Swift Lakes, near Grand Bank, Michigan. So, yeah, that's basically my background.
That's great. We'll get a little deeper into it in a minute. Go ahead, Dr. Collins. Steve Collins.
Does that work? It works.
Yes, sir.
Well, yeah, I've been doing archaeology in the Near East for the past 30 years, something like that, a little over. That's my background. Also have a background in biblical studies, Near Eastern languages, all of that, but anthropology as well. I have a degree in anthropology. So archaeology, anthropology is what I've been doing for most of my career. I've been excavating several sites in Israel and the West Bank until we got involved in 2005 in Jordan at a site that we had triangulated around the Genesis 13 map, the geographical data embedded in that text, and we tested it out, and we went to the location that it described, and lo and behold, we found everything that the biblical text describes as the cities of the plain and the infamous city of Sodom. We now know it as Tal El-Hammam. It is the largest continuously occupied Bronze Age city in the southern Levant. And so very important now from a historical point of view. We started to find in the excavation all kinds of little strange melt products, other kinds of observations like directionality in the Middle Bronze Age destruction layer. And one step led to another. Dr. Phil Sylvia connected us with, I think, Rob Hermes to start with, and then that led to Malcolm, and then it led to somewhere else. And all of
I
you
tell you,
guys,
this narrative gets old. No.
all of you guys
Phil
got sucked
Clapham
in.
called me.
Yeah.
Right?
Yeah.
Now, then I talked to Alan. He talked to him. At the same time, the Hermes thing went dead. And then I turned Alan onto it. He chatted with Malcolm, and that's why I went over there that first year, and Rob Hermes didn't.
Yeah, that's right.
Yeah, Rob didn't send me, and Alan didn't send me. I said, just for the record.
Right.
Because this has been confused.
Yeah. So you guys got sort of brought into the gravity of that project through your interest in impacts, because we thought we might have an impact, and we had a historical record that might have preserved a memory of that.
That's right. And when this fellow, Phil Clapham, he was a catastrophist from London, and you knew his old Velikovsky, and you just picture him with his leather arm pads and stuff, just an old Brit. And he calls me and he goes, George, I'm in touch with a biblical archaeology site in Jordan that suspects they may have found Sodom. I was like, is this out of a freaking movie, man? What's the deal with it? He goes, do you think the Younger Dryas Impact team would take an interest in providing forensic support to them? They're fine archaeologists, but they simply do not have the microscopy skills of your team. And I just said, that's so wild. And I called Alan, and Alan is a man of faith, so it didn't turn him off. And we managed to publish in Nature, in the abstract, the little paragraph at the top that summarized it, it had the word Genesis in it. And I said, Alan, what do you think the chances are that Nature is going to accept a paper that has Genesis in the abstract and then supports said text? He says, very, very slim. He said, I remember he said, less than 20%. I said, how long do you think you'll put up with the rejection and rewrites and whatnot, whatever kind of hassle? He said, about a year. And sent the paper in, and about 2 months later it was published. And then I think it's around up to 800,000 or so reads. For its age, it's the most read article in Nature. And I think it's in the top 20 all-time publications of Nature on that platform, which is scientific papers are lucky if 15 people read them, and usually they're the people in your department, maybe your wife, right? So we've got nearly 1 million people have read this thing, and then it was retracted. When was that?
After
6 weeks
5
ago?
years, yeah.
Yeah, after 5 years of these animals beating on them, as wokesters, because it really fired them up. It wasn't just an assault to their understanding of the past. It tickled that part where if you're a scientist, you're supposed to be an atheist. And if someone is not an atheist, how could they be a good scientist? And Steve Collins is the living embodiment of why that is certainly not true.
But anyway, that's how you guys got involved.
That's right.
We had a big boom, we thought, and we couldn't do anything. I mean, we could look at it on the macro level, but we didn't have the ability to do it below that at the micro level. And that's what needed to be done. And what the Comet Research Group did was that, and did a stellar job, you guys. You really did a stellar job with that. And it's going to hold up in the long term, because
little closer to the mic,
it's
Steve.
not just a micro. It's not just the micro proxies. We have the macro proxies that also mirror it.
Okay, again, for
And
people,
so-
because terms will come up, what's a proxy, Mark?
A proxy is a piece of geochemical or any kind of line of evidence that supports a hypothesis, I guess.
Yeah, I guess you're not going to find a video, from 12,888 years ago, and here's what happened. So you've got to kind of reverse engineer it by what's left over.
Yeah.
And
So
what's left over is often teeny tiny.
Yeah. The physical evidence of the impact event itself. So melted products strewn all over the place. Yeah, charcoal.
Nanodiamonds.
Yep.
Right.
And obviously you've got secondary proxies like
A little closer.
megafaunal extinctions and cooling periods and environmental change all over the board. So they're not direct proxies, but they're secondary proxies, I would say.
And historically, over that whole region, 400 square kilometers, we had an extinction of everything.
Yeah, that was an extinction event. It was
Humans, animals, soil, everything.
That's right.
And nobody could live there for the next 700 years as a result.
Where should we go now, folks? I am thinking that, Malcolm, I want to hear a little bit more from you and what your paper showed in 2012 and your experience. You said you kind of came in as a skeptic, and then where did it go for you personally?
Well, is this on? Yeah, okay, it is.
Just keep it close.
Yeah, that's. There's been so much. It's like the Princess Bride when he says, "There's been too much. Let me sum up."
Yeah.
It's hard to sum up because right now that Tal El-Hammam paper, if you look at the Younger Dryas Impact Hypothesis on Wikipedia, the Comet Research Group is now cast as creationists.
Yeah.
So there's a fair amount of anti-propaganda, anti-CRG propaganda, Comet Research Group propaganda. As far as there's some good examples of proxies on the screen right now, and that was where I started in this, was looking at the magnetic microspherules, then I got into melt glass and other proxies. But if you can go back that last slide, these are really interesting bits, and I'm still deeply into the microspheral evidence because it's like snowflakes. They're partially crystallized objects that are caused, essentially, they're vaporized Earth's crust, vaporized sediment, vaporized rock that condenses into essentially molten raindrops. Imagine molten raindrops in a rain, because we find thousands of these in a kilogram of sediment. So this thing must have been a rain of these molten, and the molten iron pellets or spherules are of the order of 1,400 to 1,500 Celsius. There are the glass ones are even higher. They can be up to, they can be lower as if there's a fluxing agent that lowers the temperature of the quartz. Or if they're pure quartz, then they can be up around 1,700 C. So they're very high temperature, what we call proxies, for an event that there's no other natural phenomena except perhaps lightning that'll do that. And the fact that we've constrained this to one layer that's dated to the 13,000, somewhat after the 13,000 year event, it pretty much constrains that to be a non-lightning event, but a different event. And that's the only different event would be an impact. So in any case, the original paper that followed the 2007 paper was a rebuttal by a Wyoming archaeologist named Survell with a number of co-authors. So it was Survell et al. And they tested, I think it was, 7 sites or 11 sites? I've forgotten which.
That's a long time ago. I don't know.
Yeah, a lot of sites, and found nothing that corresponded to the Younger Dryas as they saw it. But they didn't follow the protocol, and when I did the work that I did, I actually, without realizing it, mirrored their procedure and didn't find anything. And I got concerned and was alerted to the fact that I had missed a step, did the step, and sure enough, it was all there.
I didn't know that. So you'd made the same mistakes that
did.
Survell did.
I did.
Okay. Tell us what those mistakes were and what the damage was of the Survell paper. Was tremendously damaging. A paleoarchaeologist comes out, says, hey, I've looked at 11 different sites. I have looked for these proxies and found none. Right. And for a lot of people, each time those early debunkings, I guess you would call them, came out, it gave a lot of folks who maybe were curious, they just shut the door.
Yeah. Well, there were two key things that Survell missed. The first was the size sorting. And the size sorting basically makes the possibility of finding these very microscopic, the diameter of a human hair is sort of the average diameter, which is around 50 microns. And if you leave your sorting to about a 1 millimeter screen, you're going to have boulders in the way of your seeing the small particulates. But if you go down to about 150 micron screen, easier for me to say, these things become more apparent. And in fact, I went down to a 53 micron screen, and then they really became apparent. So I was convinced at that point that there was really something to this.
So it's kind of like Serval was looking for golf balls, but he had a screen that picked up all beach balls,
Well,
too.
he knew the size, but he said to me that the size sorting didn't matter. And I actually consulted a psychologist who does sorting. What happens when the human brain tries to do sorting of that nature? And he said you couldn't do it if you didn't do that elimination of distractors, the large boulders that were in your
Because
way.
what you're doing is sitting at a transmission electron microscope and moving slowly through the slide and trying to identify the things that we
Exactly.
see.
Yeah.
And these are very, very tiny, and if you have a bunch of big stuff in there, it's effectively
exhausting.
gone from your vision.
Yeah.
And then we went out to Wyoming, to Laramie, Wyoming, and
Oh,
went
yeah.
to the AMQA conference in 2012.
Yeah, that's where I met Mark Boslow.
That's right.
Yeah.
It was a very, very bad day. So,
I didn't know it then.
yeah. Actually, that was that other conference. He wasn't at AMQA, but it doesn't matter.
No, he was. He was there. He was at AMCO.
Oh, was he?
Yeah. Yep. I sat with him and
I thought he was
explained
at
the whole process.
Flagstaff when we went to Flagstaff.
No,
Right.
he wasn't at Flagstaff. I don't know about that one. I wasn't
Yeah?
at Flagstaff. But he was at Wyoming for the...
But when we went there, Serval, I'll never forget it, you went through the size sorting thing in front of the assembled, and these are all quaternary scientists
Right.
that study the last 3 million years. It's kind of the discipline, the playing field. And Serval presented, Malcolm said, you didn't size sort, and he hung his head
Well, actually...
and said, basically admitted and said, I'll have to get back to that when I have time, right? And not only that, he didn't publish a correction, and he never got back to it.
Yeah.
Then you went and did the work again.
For other sites.
Yeah.
But the 3 sites that I published the paper on were all sites that he had checked, and there were spherules at every site. There was Topper, where I collected the samples. There was Blackwater Draw, where the samples were sent to me by the curator of the site.
Mm-hmm.
And then there was Paw Paw Cove, where Darren Lowry escorted me to the site and said, this is the Clovis layer, take your samples. And there were spherules in every one of them, and they're not hard to find once you get the protocol down. The other thing he didn't do was he had a bunch of spherules that he identified, but we don't know what they are because he never did the electron microscopic procedure or examination that was required by the protocol.
Mm-hmm.
Because you can't tell what they are. There's plenty of processes that produce spherules, microspherules, including industrial contamination. That was one of the things in my talk, was the number of ways that the site can be contaminated by other things, such as biological microspherules, meteoritic microspherules, which these are not. These are all terrestrial sediment for the most part. Occasionally you'll find a very small percentage are extraterrestrial, but that's a characteristic of an impact that vaporizes the sediment of the Earth, gets it up into the atmosphere, and it rains back down as molten material. So a bad day if you're under it.
We haven't spoken to the geochemistry yet, and I hadn't heard the word platinum. What's the importance of platinum? Gunther, you want to take that?
Yes and no. Now I would talk a little bit more about the spherules.
Yeah, go ahead. Speak to whatever you like. Yeah.
And because Tunguska, because we always, like I say, impact, but we think that we are really dealing with airburst, which the only analog we have is a Tunguska. And of course, Tunguska is known only 2 pieces of evidence, which are the collapsed trees, which we, of course, cannot find 13,000 years ago. And the second are the microspherules, because that was known already from the early, 1920s, 1930s. They call it sharks in Russian, like a small sharek. And so small microspherules, but in Tunguska it was clear that you could actually see a size variation from the epicenter and how the microspheral diameter is getting smaller and smaller once you get further and further away from the from the center of the epicenter. And so the largest in the epicenter were on the order of like a millimeter size, but then they were going into the size that we are.
This is in Tunguska.
Tunguska.
Okay,
Tunguska.
and just in case people are unaware, tell us what Tunguska is.
Tunguska episode or phenomena is 1908. It was people in Europe started to notice strange phenomena that during the night they could read the newspaper and they were not quite sure what's going on. And this phenomena was lasting like 4 days. And so second day in this 4-day interval, that's when Tunguska happened. And so that was recorded also by like a acoustic instrumentation and seismic instrumentation around the world, and also by some magnetic stations. And so people in Russia, they thought, something like a big fell somewhere in Siberia. And so they were like, maybe it will be good, maybe it's a big nickel meteorite, and we can go and mine it, and we'll get something out of it. But it didn't, it took about 12 years before the first expedition led by Kulik went there, and they were very surprised because they found just about 50-kilometer diameter circle was collapsed trees. And the trees were collapsed in a way like they were taken out from the ground and they were like flown away from the epicenter. So they were very nicely arranged into like a star pattern. So you could actually go towards the trees and find the epicenter. Interestingly, they found 2 epicenters instead of just one, and there were also witnesses, because there was witnesses in a nearby village, Vanavara, and also there was they were able to see that there was actually something going like into the sky. They sometimes describe it like 2 bright pathways were going through the sky, and then there was this big, there was a large like a canon acoustic phenomena, and then there was this like flash and the fires that followed after that. Interestingly, in the epicenter there were actually some humans in their like little huts, and so they were all like thrown away into the bushes, but interestingly they survived. It was but most of the animals that were not protected from the heat, basically the heat radiation, they died in that area. And so because it was a big explosion in the air, it did not leave any crater. It just left the collapsed trees and these interesting microspherules, which I thought that there was this heat radiation. Because, I mean, just to explain a little bit what airburst is, you have a very porous body, maybe with ice, like a comet, and because the porosity is so large, it's a low density, so the density is comparable with the atmosphere. And this is the reason why the object is not capable to penetrate the whole atmosphere, and therefore, as soon as it stops in the atmosphere, all the kinetic energy converts into the heat energy, and it's basically explosion. It's like a nuclear bomb, basically, only without radiation. So it creates mushroom clouds, fires, and the shock wave, which is kicking out all these trees. Okay.
Yeah, you got to keep in mind these objects are moving 70 or 80,000 miles an hour, so 100 times the speed of a bullet. And then when they come into the atmosphere, that's essentially, in a relative way, like them hitting a solid or hitting a liquid. It's not like they just ignore the air. It's just the first dense thing that they've hit. And it's just like when someone, say, jumps off a bridge to do themselves away, right? When you hit the water, you don't make a crater at the bottom of the river, right? You don't make it that far. You kind of blow up in the water, right? But you didn't hit anything solid. If you were moving slowly, you'd have been just fine. But so imagine when that going to do this, like hitting a pond of air. And it doesn't make it all the way necessarily to the bottom, even though I was talking to Alan West the other day, and he said at the Perkins crater that there probably is a significant amount of material that that made it all the way through, right, without.
There's the contact version, and there's the purely airburst.
Okay.
In other words, they can either hit the ground with a relatively low energy release and excavate a small depression, or they can explode just above the ground, maybe a kilometer, 5 kilometers above the ground and do a lot of damage, like the Chelyabinsk fireball or airburst.
Or in Hiroshima and Nagasaki,
Or
there was no
Hiroshima.
crater,
Right,
but there was certainly a lot of damage and death.
exactly. Yeah.
That's right. But if you go back to these sites, 100, 200 years later, these that happened historically, you recorded or unrecorded, assuming they were there, because Tunguska wasn't the only one, you would have no idea where they are
Yeah.
unless you had the forensic, skills and awareness, curiosity.
Yeah.
And it was something. It's a thing, and that's what we're trying to do now. I find that so interesting. About just 2 weeks ago, the Comet Research Group published a paper where for the last decade they've been studying a location in Louisiana where a gentleman contacted us, heard from him first, and he said, I'm finding these strange rocks. My father found them, and I found them, and we think they're melt rocks of some sort, and we think we've got a depression in our backyard.
Yeah.
And the Comet Research Group gets a lot of people contacting you like that.
That's true.
But he stuck with it, and he had some heavy equipment, and he did some excavation and looked at the photos and said, holy moly, man, that looks good. And then 10 years later, and a lot of testing, and this paper came forth. So we've now found, other than Tunguska, I guess you could say, it'd be the only other identified airburst location, unless you count something like Chelyabinsk.
Or Abu Huraira. Abu Huraira.
Oh, in Abu Huraira.
Yeah.
Yeah. Well, and Tal El-Hammam.
Yeah.
Okay. Yeah. So we got 3 out of the 4 came from us. But I like the idea that, that what I've heard from some of these folks that are more cosmological about it, say there might have been 4, 5, 6,000 of these plumes.
No doubt.
Do you think?
Oh, yeah.
Okay. Is that about the right magnitude?
Well, I figure at least one every 300 years. That was Eugene Shoemaker's
Well, I would
estimate.
say no on the Younger Dryas event itself.
Oh, gosh. We don't know. We have no idea, but it was many.
I pinned
Because-
somebody down once, and they told me 5,000 or something.
Anywhere
That's
from a
just
couple
go
of
ahead.
dozen up to 1,000,
Yeah.
depending on the size.
I don't think those are out of the ballpark. I think that
Yeah.
they're very likely to be a multitude of those events.
I've also heard that the debris chain, I think this came from Dr. Napier, would have reached kind of from here to the moon. So that's a long stream, probably 6 hours or something like that. I think it
Well,
might have.
if it was a fragmented, we don't really know exactly what the mechanism was. We could have passed through the debris trail of the comet.
Yeah,
Right.
it could
And
be
that
the
could have been the
torrents, like on the screen now.
So we might not have hit with any big.
Oh,
Yeah,
yeah,
there you
I
go.
understand that. But whatever that day was, we didn't go through it for, it must have been a chunky part of the Taurid meteor stream.
Yeah.
Does somebody want to explain the Taurid meteor stream? Anybody want to take that on?
Sure. So with the Taurid meteor stream, we can see on this diagram, originally about 20 to 30,000 years ago, I think the calculations are, a giant comet entered this inner solar system, and it became trapped in an orbit between the Sun and Jupiter. And as it travels around the orbit, it starts disintegrating, and early in its disintegration, it's quite large chunks, and as time goes on, those large chunks break down smaller and smaller, and as they're breaking down, they spread out as well. And so Earth passes through this debris trail twice a year.
In late June
Yeah.
and early November, late
Early
October.
November, yeah.
That's
Yep.
right. Now let's think about those 2 dates they're interesting. Tunguska hit when?
June 30.
June 30. So you might suspect that was just one big shooting star, because you can go out and see airbursts all year
Yeah.
long on a good
There's
clear
airbursts
night.
happening right
Those
now.
every shooting star you see is just a little version of what happened that terrible day.
Yes.
It's just that you had 50-meter objects coming in instead of sand grains.
Yep.
But they still don't make it to the ground in all cases.
Yep.
Or in the vast majority of what we think happened that day. I wasn't looking down there. So did you have some of the Perkins materials?
Not in this presentation, but
really?
I can pull it up.
Yeah, when you get a chance,
Yep.
put some of that, just because those big blocks, or you could just call up the paper itself. Right? Steve, let's talk about the retraction of Tal El-Hammam. Why did they retract the most read scientific paper of the last 20 years?
harassment.
Who
I
was
think-
harassing who?
You know, Boslow and a couple of other people were harassing the editors of scientific reports. That's what it looks like.
Right.
They really had no real argument. They didn't really challenge the science, and I think in the right way. They've been all over it since the beginning. Boslow in particular.
Right.
I mean, just pounding. I had a lot of interaction with him, and lots.
When?
And
This is one of our principal
up to
critics and
about-
antagonists, Mark
up to about
Boslow.
a couple of years ago. I had a lot of email interactions with him, and he would say one thing on the email, and then turn around and say something else completely different on the internet. And so there was no way to carry on a legitimate scientific conversation. And but he did tell me, I quote it from his email, that if you can find directionality at Tal El-Hammam, you've got an airburst. He said that to me.
Right.
And we've got all kinds of directionality, and he's still
Talk
screaming.
close.
Yeah. So,
I got to do it too.
yeah, you couldn't have any more evidence, I think, of an airburst in a location than what we have at Tal El-Hammam. I mean, it's just stacks. It's the macro and the micro. It's all there. But I suspect that somewhere deep down in there, the ultimate reason why they kept pushing so hard to get it retracted and why ultimately it was so easy for the editors to peel it back was simply because there was a biblical reference in the paper.
No conclusions.
No,
Just- yeah.
no. All they said was, you asked the question in the paper, is it possible that this particular airburst event toward the end of the Middle Bronze Age gave rise to the story that eventually wound up in the biblical text as the Sodom destruction? It was just a question. They didn't even like the question. They don't want to entertain that at all.
So it's an interesting comparison between the retraction of a very popular, very dense, very technical, clearly a lot of time, effort, and expertise put into that paper, and it was retracted on very thin basis, basically manipulation of photographs, right?
Yeah, I mean, that one, the first reaction to it was that the very title itself was clickbait. Right? The whole idea of having a site that could be biblically connected, they just were all over it. And but one of the things was that they saw they were looking at the metadata in the photographs, and they were charging that the photographs had been doctored. Well, if you want to call putting on a title onto a photograph or an A or a B or a C, to mark features in the photograph, and someone else in the process taking those off and putting in a different font to better match the paper. If you want to call that doctoring a photograph, then okay, yeah, we doctored the photographs, but what we were doing was marking everything specifically, because if a non-specialist or someone who wasn't familiar with it looked at the photograph, they'd go, oh, I don't know what in the world I'm looking at. So we marked everything on that and put tags on it, and so for publication, they removed some of the tags and put the font that would match what they wanted to use, because those were what we had put in on the excavation side. And so anyway, we immediately sent all the original photos, untouched, all the original photos to the editors. Say, here are all the photos. And they looked at that and they went, well, there's nothing kooky going on here. The original photos are exactly what's represented in the paper. There was no difference. But see, that little strand of that idea that somehow there was some funny business going on with the photos, gets out there and circulates, but people don't chase after it and find what the end of the story is.
That's right. Yeah, the short attention spans are challenging.
Yeah, exactly. And so, they were accusing
willful ignorance.
They were accusing us. Well, I was not on the original paper. But and by the way, I told Malcolm and everybody else, I said, please, in the paper, don't mention Genesis and don't mention Sodom.
Yeah.
I said that. They said, why? We would be remiss if we didn't make that if we didn't make that historical connection, somebody's going to see this and they go, well, did you not see this? How come you guys didn't make that connection? And so they didn't want that to happen. But I said, you guys don't know the archaeological community. I mean, you work in the hard sciences. I work in the flaky sciences.
Yeah.
And so you don't know what these people are going to do, because there is an operative, heavy-duty anti-biblical bias operating out there in the archaeological community in general.
Sure.
And I called it, I've just written a series of 10 essays called Sodom Derangement, Treating Sodom Derangement Syndrome. Because what happens when you mention biblical Sodom, people's minds see the synapses, I think, in the brain like misfire, and everything goes crazy, and people just can't think logically and reasonably. I don't know why, but it just seems that way to me. And so I've got a treatment program now going for people to help them logically and scientifically and reasonably think through this issue. But hey, we got an impact. We've got a destruction like nobody's ever seen at our site. It makes Pompeii look like a walk in the park.
Mm-hmm. And that had been, just for context, about 3,700 years ago. In the Younger Dryas event, which may have been that same meteor stream, was roughly 13,000. Malcolm.
Yeah. The second attack was on the directionality issue, and that was put to bed very quickly. Well, not quickly, and not necessarily easily, but the collection of the images that showed directionality, without a doubt, that put that to bed. And then the last and most, I guess the one that they kind of exceeded the tolerance of the journal editors to just contemplate future harassment, was the suggestion that we had misrepresented it as being Tunguska sized.
That's right.
Given that at least one analyst investigating Tunguska had sized the event as about a 3 to 5 megaton event, whereas virtually everybody else in the community says it's closer to 20 to 30 megatons. Our estimate was somewhere between 15 and 20 megatons. So we were right in the bell curve, right in the center of the bell curve of what our estimates are, but that wasn't unacceptable. Mm-hmm. So
I'd like Mark to draw a contrast with us with a story he's very familiar with and something he ran down, kind of playing their own games against them. Okay, so you can see the standard that the Tal El-Hammam paper was held to was very strict and very high, and maybe that's the rules, you know? Maybe that's the way the game's played, but you want the same rules or the same game to be played for all participants. Discuss your effort to get one of their papers retracted, and that's the Sun et al. Paper of 2020. Mark, tell that story and what other depth you like.
Yeah, sure. So Sun et al. 2020, it was a group of scientists who published this paper claiming that the Younger Dryas boundary layer in Hall's Cave was actually produced by a volcanic eruption. And so
which rocketed around the press, and there were a bunch of articles that said, you know, comet theory disproven, volcanoes now culprit.
Yep. Yes, and so very quickly after it was published, Dr. Martin Sweatman went through it and published a YouTube video basically eviscerating their methodology because it was very sloppy work. But the methodology is not even the start of the issue with this paper. So if we look here in the yellow column, you can see their sample interval is a nice clean 1 to 2 centimeters between every single sample. Except in the blue box there's a 4 centimeter gap between those two samples. So I thought that was odd. And shortly after he published that video, Dr. Thomas Stafford contacted us. He's the principal investigator at Hall's Cave. And back in 2009, he worked with the Comet Research Group on finding impact proxies in that cave. And so the layer that contained the impact proxies in that cave was 153 centimeters. And coincidentally, that's the sample that's missing in that 4 centimeter gap. So as it turned out.
Okay, say, just repeat that. That sample turned out to be the target of the study.
Yes.
You look above, you look below. Yeah. You have an area that may or may not be enriched, and that's the Younger Dryas boundary layer with the proxies we discussed.
Yep.
And then now you say it was around 151 centimeters, or would it be 52, 53, 54? Yeah.
In 2009, the Comet Research Group found impact proxies in the layer between 151 and 153 centimeters. And that level in the cave is what's missing from Slenderdale's data. And so Thomas Stafford sent us the original data from the study, because he was originally a co-author on it. But when the authors ran off and submitted it to the journal without his approval, he wrote to the journal and said, take my name off of this. And so he sent us all the draft stages throughout the entire process and the original data. And as you can see, the original data in the sample that was deleted at 153 contains a massive platinum spike.
Okay, so if you look down that column, folks, started at 275. So do you know what is that, parts per million?
PPT, I think.
Okay, parts per trillion. Yeah. But that's the metric, whatever it may be, and it's consistent across. So 275, 185, 900, 237, 128, 72, 1,807.
Yes. So it's more than 10 times the highest, or almost 10 times the highest.
Now imagine that, folks. They eliminated the area that when you go and find the original data, you see that was
and so
confirming.
Even if this sample wasn't at 153, we know from a dozen sites around the world that the large platinum spike occurs at the onset of the Younger Dryas. We use that as a global geochemical datum. When we find the platinum spike in the vicinity of what we think is the Younger Dryas layer, we know that is the Younger Dryas layer because the platinum's there.
Okay, why is platinum there?
Well, that's the question, isn't it? All we know is that there's a correlation of platinum at the Younger Dryas boundary. We don't know the mechanism of how it got there. Presumably it came from the impactor, but we don't know for sure. Something put it there.
Because there's a kind of an expected level of platinum, which, let's say it's around those, the 270s, 180s, and whatnot. That's kind of stuff you see. And it's then very unusual to see that much more, so it had to have a contribution from elsewhere, and that's from above.
Exactly. Yeah. So normal ET impact elements like iridium and osmium and stuff, but all of the metals in the platinum group are associated with impactors, like extraterrestrial bodies.
And that same geochemistry was used to prove that the comet killed the dinosaurs.
Exactly. That signature was iridium, and that's when they found large concentrations of iridium in this layer, they knew, holy crap, this thing's from space.
Mm-hmm. You might mention Petty.
Yeah. So we first found the platinum in, I think I've got a slide here, in the Greenland ice core. They were actually aiming to disprove the Younger Dryas Impact Hypothesis, and they went and looked for iridium in the ice core, and so they thought, well, if we don't find iridium, we can put this to bed. But what they did find was a massive platinum spike. And so in the years since then, we've also found the platinum spike all over the world at the Younger Dryas onset. We've got it in South Africa, we've got it in southern Chile, we've got it all over the USA, and we've got it in Syria as well, at Abu Huraira.
Yeah, I could talk a little Wally Broker. Hey, you don't happen to have that memo of his handy. Could you find that?
I don't.
Are you online? Could you go to the Cosmic Tusk?
So if it's on Cosmic Tusk, I can probably get it.
Yeah, search in the search.
I did know, I was searching for it recently, and the university page that hosts it has actually taken it down.
Yeah, but it's reprinted
versions
on the Tusk unless somebody hacked me.
Yep.
See if you can find that while we Gunther, do you do just materials or do you do geochemistry?
Well, I'm mainly focusing on magnetism because my area of expertise is like a rock magnetism, paleomagnetism, and so in this aspect we are looking on the magnetic proxies, not just the proxies geochemical.
Right.
And so when we combine them together, we see variation. For example, one of the variation appears to be increase in so-called magnetic susceptibility, which is of course probably due to presence of these microspherules, because they are mostly from the metal, which is a highly induced magnetic, and this allows you to, if you scan the core, you can see a spike in a so-called magnetic susceptibility or magnetic signature. So that's one thing. We also are trying to measure magnetic remanence, which is a different feature, but that has a lot of catchbacks, because the sediment in the lakes usually can chemically recrystallize, and therefore you have to be very careful when you are treating a core of lake sediment using magnetic method. This is also connected with the sediment environment, because very often the lakes are they are always at the bottom of the valley, and therefore in order to get the sediment, there's streams that have to carry the sediment into the lake, and so there is also kind of a catchment dependent chemistry, because the larger the catchment, the more chances for chemical changes as the water percolates into the lake. So usually it's easier when you have a smaller catchment, and so you can rely that there is a least amount of chemistry, local dependency in that lake.
Mark has found the broker brief, and I came across this. I don't exactly remember what I was Googling or whatnot, but I was surprised to see a memo written by the father of global warming, I think they call him, right? He was the first person to actually attach greenhouse warming. I don't know. He came up with he was the head climate scientist at the same lab that Dr. Abbott is from, Dallas Abbott, and that's Lamont Doherty at Columbia University, and it's one of the top geoscience labs in the world. And he was the number one climate scientist and the go-to guy from the New York Times for 30 or 40 years on the subject. He was Mr. Global Warming and is widely acknowledged as such. So and he's also acknowledged as having defined that period, that term that you've heard so much, Younger Dryas, having defined that period as a snap of the climate. And that, as he said, we had poked the beast, or we may be poking the beast of climate, and if you poke the beast, sometimes it can go wild. Well, he used as the example the Younger Dryas. It got much colder. So literally, overnight or close to, we found out at first they thought it took 1,000 years for it to get so much colder, because there's a tremendous 1,200-year cold period that where temperatures dropped 20 degrees in the Northern Hemisphere. And they thought it might have taken 500 years to get that way. I think in the first becoming aware of it in the 20th century, then it was like 250, then it was 100, then it was a couple of decades, then it was a decade. And now even the mainstream admits that it was virtually overnight that the temperature dropped 20 degrees. So Broker was well known for having defined that period, the Younger Dryas, and then he utilized it as kind of a scare weapon in the climate debate to say that climate can snap. And this way, at this time, it went cold, and it was probably water coming into the Gulf Stream, and it shut the Gulf Stream down. And then you would ask them, okay, well, where'd the water come from? What came from the ice sheet? Well, how'd it come from the ice sheet? Well, the ice sheet broke up. Well, what broke up the ice sheet? And that's where they stop. So they don't admit it a catastrophe. Just the water part, not what made the water go into it. Because we agree with all of that. It's just that we think something hit the ice sheet and caused it to shatter, drain catastrophically into the Arctic and the North Atlantic, when that would have shut down the Gulf Stream and begun the cold period. Okay, so the father of the Younger Dryas and global warming, Wally Broker, then writes a memo to an internal memo to his lab, and zoom it up a little bit if you could, Mark. Can't you just pinch it kind of wide, or not pinch? or Control plus. But Control plus will open up the thing, won't it? Okay, I get it.
There you go.
Yeah. So let's read that first paragraph, and then I'll go get go to the top one. I don't know. I understand. So this is the paper that we published in 2007. When the Firestone analysis scenario first appeared, I was shocked by its grandiose claims. The comet did in the Clovis people. It created a fire extending over at least 2 continents. It was the cause of the extinction of large mammals in North America. Then, when it was shown that there were no buckyballs and no iridium spike, I joined many others scorning this idea. Later, when as part of a NOVA show, later taken down from NOVA, it's no longer available, Mark Boslow hounded them successfully to remove the PBS NOVA about our discovery, which is it's like burning your book. The claim was made that nanodiamonds were present at the YD onset in an outcrop of Greenland ice. I backtracked a bit. So then he's questioning his own skepticism. But as questions regarding the occurrence of nanodiamonds cropped up, I relapsed to my negative stance. If you don't mind, I'd like to read. When Alan Zindler, a friend and former colleague, asked me for suggestions as to how he might raise salary money to extend as a temporary appointment, I suggested he propose a search idea for an iridium spike at the YD. My thought was there'd be no spike, and hence a fatal blow would be dealt to the hypothesis. Remember, this is an internal memo. Zindler sent an NSF grant got an NSF grant with 3 months' salary. Also obtained a stick of GISP-2 ice. This is an ice core into the Greenland ice sheet, which contained the onset of the YD. Planned to do the analysis, but alas, things got busy. Scroll down just a bit more if you could, Mark. I know it's tough. Having thought that it was dead, pleasantly surprised when I received a preprint from Jacobson documenting a 300-fold increase in platinum right at the YD onset. The rise and decay times of this peak were consistent with an air blast. The platinum suggested that it was produced by the impact of an iron asteroid. The absence of a companion peak in iridium suggested there was a rare differentiated iron, blah, blah, blah. This paper, entitled Large PT Anomaly in the Greenland Ice Core, points to a cataclysm at the onset of Younger Dryas, was published in 2013. That was a good day. I remember when that came out. Get on this next page, and we hit the really good stuff. See, this thing is embedded in with the old embedder, sorry. Can you just change it to page 2? Type 2 in instead of 1. There you go. Let's take that second paragraph without all this reading. Yeah, I remember this guy was a terrible antagonist at Science. A reporter who was the lead reporter in Science magazine wanted nothing to do with this. So I remember pleading with Science's Richard Carr to do a piece on this discovery. He thought about it and decided that as he had written a very negative piece about the original idea, he didn't want to revisit the subject. So since he had come out as a skeptic in his reporting, not personally, he was unwilling to report very, very well credentialed follow-up confirmations. It's just awful, just zero integrity from the fellow. The 18 authors included West and the claim they had found microspherules, blah, blah, blah. So he go through, and he's going through our other evidence. But let's go to his third paragraph. That my take on this is that the Greenland Platinum Peak makes clear that an extraterrestrial impact occurred close to the onset of the YD. Perhaps the object was vaporized in the atmosphere, blah, blah, blah. And then down to this is the key. Although I don't for a minute believe that this impact did the Mammoths in and the Clovis people, I do think it triggered the YD. Now, his whole career had been centered around the Younger Dryas being a sudden and unexplained snap in climate, and he had never considered that there was a forcing agent outside of the Earth itself, that there's more going on. It's not all home cooking on Earth. Sometimes you get, something from above, and here he admits that in crickets. It doesn't matter. You can take the absolute top authority on the thing at the top school with all the accolades you could probably, you could imagine. Hell, he must have had a 2,000-word obit in the New York Times. And And he backed away from it at the end and said he thinks it was an impact. Shows you how, this is a tough game. It's a tough game. So, where shall we move on to here now, ladies and gentlemen? What's on your mind, Malcolm?
I'm happy to follow up with that I personally don't believe it did all the things that were claimed in the 2007 paper. I don't think it was the cause of the extinction of the megafauna. I think that happened more slowly and over time. I don't think it caused the extinction of the Clovis culture. I think the Clovis culture probably survived in a different form or reorganization of some sort, and it survived with a bottleneck, perhaps. I'm willing to accept that. In the paper that, the first paper we did, which is 2012,
Right there.
we did an experiment that I thought was indicative that, and this was due to Al Goodyear, who was the main person at the Topper site where we got those samples. Al wanted to try, and he suggested that we try to sample both the dirt above the debitage in the quarry at Topper and the dirt below the debitage. In other words, the flake particulates that come from napping a point were left on little pedestals.
Speak closely. Yeah.
So we were able to differentiate between sediment above and sediment below these fragments of points that were being created at the Topper quarry. And what we found was that they disappeared below, and above they are abundant. We had-
So there's no impact proxies below the points.
That is
They're
correct.
only on top of the
So
point.
they're casting a shadow.
Yeah.
As the
Exactly.
stuff is raining down,
Yeah.
you see it around it, but if you pick it up and test the little area beneath the point, you don't find the proxies.
And we did the same experiment at Bowser Road, New York, found the same thing. The mastodon carcass is draped with impact proxies, including melt glass, spherules, platinum. You go below, nothing's there. That's a different site, but two experiments to two different sites, and we get the same result. So that I think kind of, and the quarry was abandoned after that. And abandoned doesn't mean everybody was killed. It just means that they moved off.
Well,
for
let
some
me give
reason.
people a little background. Topper is an archaeological site led by the chief archaeologist in South Carolina, Dr. Al Goodyear.
Now retired.
That's right, and we visited that site. I've been down there a couple of times. And Al became controversial because he found what are supposed to be, supposed to be the first tools in North America, the first spear points that are called Clovis points, and I actually have some up in my room. I should have brought one, or at least a fake one. These beautiful lanceolate spear points with what do you call the thing?
Like the one on the
bottom?
left of this.
Oh, thank you very much. Those things. Okay, so he found those in abundance at Topper. Well, that's great. That's a huge archaeological find. He found, a Clovis habitation area and a campsite and a quarry. When he says quarry, they were actually taking that chert there and manufacturing these points beside the Savannah River, at the Savannah River test site, a nuclear facility, coincidentally, in South Carolina. But then, I forget exactly how the story goes, but he went ahead and dug deeper.
Yeah.
There's not supposed to be anything under that. That's the last airhead you ever find. And he went back 50,000 years and found things.
Yeah.
And that put him way outside the mainstream opinion of his discipline, where he has remained since, despite being a very, not only credible, but a distinguished archaeologist. But you're not supposed to dig any deeper than Clovis. And then he got in trouble. And that's when he started testing for Younger Dryas materials in that same site. And he joined the Comet Research Group and said, we found all this stuff.
Yeah.
Let's get some questions from the audience if there are any. Yeah. Okay, Joe Kappa. Get day 3, you start remembering everybody's name. There you go. Oh, Joe. You got a mic coming from Joe. You got a mic coming.
Thank you much. I've been the guy bothering everybody for signatures for my petition to change to 432. So you may have seen me talking my head off, and that's why I'm a little hoarse, so you'll forgive me. I was very fascinated in the YDIH, and I decided, well, if we've been here for 300,000 years, and there was such an event that was a cataclysm that sent us into 100 years of darkness and 1,200 years of nuclear winter, the human record would tell us everything about it that we need to know. So I started researching, and I was using AI, which is an unbelievable tool. Halloween is the annual memorial of the night 7 comet fragments slammed into Earth. The first one blew up in the sky over Siberia, and the sky was black and orange. The sky was on fire. So Halloween is actually the memorial of the night. So we not only know that it occurred, we know what day of year it was, and we know from the Celtic and Germanic tribes that it was 1 hour before midnight that the sky caught fire. So we know it was 11 o'clock at night European time that this event started. We also know from those same legends, at 3 o'clock the whole earth went silent. So the whole event took less than 4 hours. And the first one hit over Siberia, and if you read the book of Revelations, it talks about the woman is Mother Earth, and she sat there pregnant, bearing all life, and the red dragon came to devour the child. But Michael, the archangel, the other comet, Enki, who we passed by every harvest season, was our protector. And he shattered the dragon into 7 pieces and threw him to earth, each one a trumpet of doom. And the book of Revelations tells you what each comet did. The 6th one hit the Laurentine ice sheet over the Great Lakes, and the 7th destroyed the lake at the Columbia River Basin. The 7th one was described in the book of Revelations as God's kingdom come. End of chapter.
Normally, when people hold forth, don't ask questions, and start, quoting Revelations, I get uncomfortable. But that was actually a nice contribution, Joe. Thank you. Does anyone have a question? I don't think so. I mean, you'd have to interpret it.
My question was just the paper that you had up earlier. I think it was Sun et al. The first spike at 143. What time period did that correlate to? I think it was like 940 some for platinum.
You mean the platinum spike? So that layer dates to 12,800 years ago. The 1800 spike, yeah. So, okay, good question. So the 965 spike, about half as high as the one at the Whitey onset, that marks the Whitey termination. That's where the Whitey enters into the Holocene. So that platinum spike occurs right there. I've noticed that too, and I find it interesting. We haven't done any impact research on the end of the Younger Dryas.
You're exactly right, which was as dramatically sudden as the start of the Younger Dryas.
Yeah.
Which
Well,
somebody's got to make a movie
sudden.
one day.
It was more sudden.
More, well, yeah,
Yeah.
okay.
Yeah.
And somebody's got to make a movie one day. I mean, you've got we go from plucking pears to pulling plows, in the movie. And it starts out, we're living in a, Eden-like setting and taking care of ourselves with subsistence living and hunting and gathering and probably relatively happy. And then things go to absolute hell for 1,200 years. And the last thing that you would think is you would pop out of it in a year. And all of a sudden, everything's okay again. And the climate has been incredibly stable since then, which kind of fits the biblical narrative of giving us another shot. And you don't have a YD graph or at least a long-term graph that shows how stable it has been since then, do you, Mark?
Yep, 1 sec.
I mean, it was wild and woolly for 200,000 years. Then you have a dramatic drop of the Younger Dryas. Then we pop out of it. And then a smooth sailing, more or less, in a relative sense, for the next 13,000 years. That's right, but
Yeah.
they're barely dips compared to, yeah.
Right.
Look at that. I mean, it's really, the Younger Dryas is that last collapse there, and then we pop out of it, and look how stable it's been. I mean, that you would say that's unprecedented stability. Very, very interesting.
At least throughout the last ice age, yeah.
So I've been trying to split the difference between Robert and Randall. I tried last year, and Robert body slammed me. That I just think we should settle and say, okay, Comet started it, and the sun ended it.
Well,
Yeah.
the interesting thing is, at 14,600, there is a very large solar event there. There's a large Miyake event there, which is characterized by the cosmic rays that bombarded and produced like a C14 anomaly. So, and that is right at that big heating spike just before the Younger Dryas. So there was a massive solar event 2,500 years before the Younger Dryas boundary. So I don't know if the sun ended it or if it preceded the Younger Dryas event, but it's pretty safe to say there was some solar involvement in the previous few thousand years.
Well, you got to think in all those periods of warming, there must have been a lot of new models of SUVs each time you see that thing pop up.
Yeah.
Okay, anybody else from the audience? What we got? How about you, sir?
Thank you. For those who may not be familiar, I was just curious if there are any commonalities in the proxies between a coronal mass ejection event and a cosmic impact. Are there any similarities
It's
whatsoever?
a good question. I don't know. Anybody feel qualified for that, or gotta?
So CMEs would deposit mainly cosmic rays and radioactive elements, I guess. They're not known to produce impact proxies like what we see. And I think in Robert Schoch's scenario, the proxies are produced by lightning storms that are triggered by the solar event, like super lightning storms, thousands of strikes per second, per minute, whatever. And so that's the only reasonable way that these proxies could be produced by a solar event, I would say.
I also find it. Well, Malcolm, you had a little something to say on that, maybe? Did you?
Can I say
Oh, yes,
something?
absolutely, Gunther.
Just to clarify, because when you have a large amount of plasma which is aiming towards the Earth, it is also impact, because right now the Earth's magnetosphere is being impacted by a large amount of these particles that are both positively and negatively charged. And so in effect, that's the impact as well, only it's only in the upper atmosphere. But what's interesting about it that it generates these like a large electric currents that could be then transparent into the like a lightning discharges. There is some weird lightning that can go all the way from the upper ionosphere all the way down. And so in a way, NASA has some like a research that is investigating these specific events because they can produce lightning.
Sure.
So I asked a certain PhD regarding the difference in mammoths found in Siberia in situ with food in their mouth versus those mammoths found in Alaska that were completely obliterated. And what I was trying to allude to was a common impact event based on carbon-14 data, but he seemed to kind of not poo-poo the idea, but that it was a wide space of time, could have been 10,000 years or greater. Can you speak to that?
Yes. So the flash frozen mammoths, the ones with the food still in their mouths, those kind of things, they tend to date to between 30 and 40,000 years ago. There hasn't been any found, as far as I know, that date to the Younger Dryas boundary. The Comet Research Group has done a study on, John Reeves' Alaskan boneyard. And
Without being in touch with him, they did it by proxy with the material.
It wasn't his boneyard. It was a very similar boneyard. I think the one that we did was in Siberia, not Alaska, but I could be wrong.
No, it was Alaska. They were testing the materials from the boneyard in Alaska.
So, but the boneyard extends far outside of John Reed's property.
Absolutely.
And it's probably the same thing that we see in Siberia. It's probably
Absolutely.
all one big thing. But
30 to 40,000 years ago.
Yeah. And so these megafaunal skulls were found with impact spherules inside their skulls. So whether they probably washed in there with sediment, they probably didn't fly through the bone, and because
That's right.
You've got tusks with meteoric material embedded in the tusk.
Yeah, my tusk has meteoritic iron embedded in it, but it doesn't make sense to me. I'm a skeptic about my own tusk, coolest thing.
Yeah.
I just don't see the physics of getting a little particle from a airburst to bury into a tusk.
Well, if it was red hot when it landed on the tusk, it could kind of.
No, during a tornado, a straw can be driven through trees.
Yes.
Yeah.
So, but how would you have an already quenched fragment of meteorite riding the shockwave, you'd expect it to be like molten or plasticized to some degree. Yeah.
Gunther, at Tunguska, did they find them embedded in the wood?
Well, what I want to say is that this is one of the criticism that was on the Tal El-Hammam paper, that the idea about the modeling of the airburst is that it's like a homogeneous pressure wave, because the model is not assuming like a discrete particles, it's assuming everything like a homogeneous mass. However, and it was argued that when you have an airburst, it's a discrete event, which means that you have a packet that can actually be driven with very high velocity into the ground and perhaps cause like a immediate like a shock event, and that's why there is an interpretation that some of the shock quartz that was found in Tunguska is because of these discrete packets that were actually penetrating and hitting the ground. So this would be the answer to your question, that if you would have an airburst which would contain like particles, they could be driven with very high speed and penetrate your tusk.
Well, that makes me feel better. I've never really had a full talk about it. I don't know. Okay. Okay, and it dated to 37,000 years old, which you can see that number pops up kind of like 13,000, right? Where varying things, you'll just be reading about something unrelated and you go, huh.
Yeah.
So there was a dramatic decline in this, or there was a geometric reversal in, it'll always be about 30. And you saw Armando May's books yesterday. What was the date on all of those?
36.5.
It was all 36.
Yeah.
I mean, something happened back then,
Yeah.
man. And my great hope is, and I've tweeted it again, and I'm going to get to it. I'm going to try to do some of these high-level invites sooner rather than later, but we've got to get John Reeves at this conference. Yeah. Not only that, John Hagstrom is ready to go up there at a moment's notice and give him the investigation that he deserves of that is unbiased and open-minded and qualified. And that's all he was calling for on Rogan, but we just hadn't been able to get through to him. I got through to him once inviting him, and he said, can't do it, that's mining season. And then my whole part about, hey, can we come up there and test your site and fulfill what you have said to Rogan that you wanted to do, he didn't answer. Probably just attention spans again. But they pulled one out 2 days ago. That's why I tweeted it, and with an invitation that was just an absolute blackened from tip to root 10-foot long mammoth tusk, completely just charcoal. And he was hinting in the thing that something, he didn't hint, he said something very, very, very hot treated this tusk.
He's got a lot of scorched bedrock in that boneyard as
Does
well.
he?
Yeah.
Man, we got to get in there. Okay, anything else from the audience?
Is it a question or a comment?
It's a question and a comment. The first question is, Dr. LeCompte mentioned protocols in reference to proxies. What determines a protocol? What is it?
It's just a list of procedures that you use to process the sediment and extract the things you're looking for, the protocols that point to an impact event, those things that are left behind by an impact event. So the protocol is designed to enhance your ability to pull those out. So you've got a number of steps you should follow, adhere to.
Including sieves.
It's a cookbook.
Okay, thank you. I was asking for somebody else, asking for a friend. But the last comment I wanted to make as far as that human record I was mentioned earlier, the dragon from China comes back, although he's white the second time from their point of view. The first time he blocked out the sun because it was 6 o'clock in the morning their time, if it was 11 o'clock Europe time. Quetzalcoatl, the feathered serpent, we saw him streaking across the sky. He had union with his sister, went to pieces, lit himself on fire, threw himself to the earth. But they all say, the Chinese dragon and Quetzalcoatl and Enlil all say the same comet came back. He washed the earth clean, he landed and emulsified himself in the Atlantic Ocean, caused a global tidal surge that basically washed about half the world out to sea in one terrible day and night. And the world was washed clean, and he brought months of rain, which restored life to the planet. But they all say it was the same comet that returned that did this. The one that started it also ended it.
The story of Phaeton as well, I think, correlates quite well with what we would expect.
Yeah, I wish we had a mythologist here. But go ahead. Can you speak to Phaeton?
I don't know the story off by heart,
Yeah.
but there's definitely, particularly in Ovid's retelling of it, there's a lot of, I mean, he specifically says it flies between the moon and the Earth, so it's closer to the Earth than the moon. And apparently it grazes close enough that it spalls off some objects. So whether it's like a giant comet passing within the moon and it drops some debris as it passes.
Oh, that reminds me of kind of two little weird things I think about sometimes, or actually first in that weird, but the word disaster, what is the root of the word disaster? Disaster, bad star.
Yeah.
Right? It's a bad star.
Yeah. And Randall's got hours of these little synchronicities.
Yeah, and then look at this is home cooking here, and nobody else is interested in that, but I'm going to say anyway. But if you look at the Arab flags and the Muslim symbol, with the crescent moon and the star, where is the star?
In the middle of the moon.
Okay, how do you see a star behind the moon? That's the easiest way with two symbols, just two, to communicate that sometimes there are things between us and the moon. All right? Why else would you show a star within the thing of the moon? I think that's kind of neat. I don't know exactly what they mean, but of course, and when they go to Mecca, they all have to go once in their life and worship a meteorite.
Yeah, inside
that's what
the
they're
black
walking
box.
around. There's a meteorite in the Kaaba or
Yeah,
whatever.
yeah. That's what they're worshipping, basically, a giant meteorite.
That's right. They go and kiss it and burst into tears and go home.
Yeah.
Yeah, 1 billion people. Okay, other subjects we should address. Doesn't have to be a question, just things that are in your head that you'd like to hear people talk about. Yes, sir.
She was just asking me the other spikes that we see on this graph here. Have you guys ever collected any of those spikes?
No, because I tell you, there aren't the resources to do that kind of stuff. I mean, that's absolutely what you would do if it became a subject of legitimate, supported national research. There could be teams looking at that kind of stuff. And just the YD, I've always felt, if you could spend, $5 to $10 million with an NSF grant, you could go all around the world and test shallow archaeological soils. It's not that expensive. It's kind of tedious, but for $10 million, you could put this thing to bed, right? But we had a big donation a couple of years ago from a wonderful angel whose name won't reveal, but gave us $3 million. And we started a crowdfunding fundraiser this weekend, actually, for the CRG, right, to see whether we can kind of follow up that grant, because that's going to run out relatively soon, to see whether we can widen the scope of things, because a lot of this, Malcolm, anybody paid, how many hours have you spent on transmission electron microscopes looking at proxies?
It's months.
Months. Yeah. You don't measure it in hours.
No.
You'd go to the NC State lab.
It's 3 hours a day, once a week.
Yeah.
Sometimes twice a week.
Yeah. For a long, long time now.
I go to ECSU now.
Has anybody paid you yet?
No.
Okay. Well, how many people are you going to find like Malcolm that are both qualified, have the time on their hands, and are willing to, put countless hours doing something terribly tedious? It's just a hard thing to scale. We're lucky to get where we are. It's a great question. I don't think they're all related. But I don't know. What's your take? Yeah.
So the question was, have we tested all of these previous spikes here?
Yeah.
And the climate scientists consider these normal oscillations. Obviously, looking at them, you could assume they're pretty catastrophic, right? Because large temperature changes like that would cause havoc on Earth, but they're still considered normal by climate scientists. They don't seem particularly alarmed by them. The thing about the Younger Dryas is it's very different to all of these previous ones in a number of ways.
Yeah, the Younger Dryas departure, going from warm to cold, was at a time when the solar insolation on the Earth, solar heating of the Earth, was larger than it is today. So it was a sudden and unexplained reversal of that climbing temperature coming out of the Ice Age. The Earth was warming, and then suddenly we went back into it for no apparent reason. And you've seen how stable it is during what we call an interglacial or an interstadial.
So can I talk about these environmental records in
Sure
general?
can.
So, Mark, if you'll go back to that first one that the question was about, this is an ice core record, and we get those from Greenland or Antarctica, and Lonnie Thompson has taken like some mountain ice cores. But typically, it's either Greenland or Antarctica. We get these ice core records, and they're varved. So it's every year. So that's a nice thing, you know, that we can check our chronology roughly. So what you're looking at here are oxygen isotopes, which in general scientists attribute to temperature. And it's the fluctuations between the amount of water that is locked up in the ice cores versus what's in the ocean. So that's kind of the fluctuations you're seeing there. As far as other environmental records, we've got marine cores, and they look at oxygen isotopes from diatoms and foraminifera, and radiolarians and so forth. So for the terrestrial record, it's the lake cores, but the lake cores are only going to go back, you know, maybe 20,000 years for close to the Laurentide ice sheet, maybe further if you've got a deep lake, but typically, you know, those are shorter records, and you can look at more things such as diatoms and gnats and pollen and charcoal and sedimentology and so forth. So that's kind of what we're limited by. And so also when you're writing a research project, you're focused. So you're going to pick, you know, unless you design your research project to say, oh, I'm going to look at the high points within the Eemian or a certain part of the Pleistocene or whatever, you're typically going to focus in on something. You've got to have a particular point to your research project. So in my case, it was, is there a fireball at the beginning of the Younger Dryas? Well, I can't just pick, you know, a 2-inch span of that lake sediment. I need to do a swath to put that in context. And so then when I'm doing my analysis, you know, I'm going to take it every centimeter. That's how I did it, every centimeter for maybe 5 meters. So that's a lot of data and a lot of work. So that's the limitations that we have. You know, you have to pick a specific thing you're going to address. What's your research question? And then, you know, you've got a certain amount of time. So those are kind of the constraints that we have.
Yeah, and so as I was saying earlier, the Younger Dryas boundary differs from all of these previous events in a number of ways. The graphs up the top, on the left we have the Younger Dryas episode, and you can see 5 frequencies increasing towards the Younger Dryas boundary. But in the last 19 cooling events, the 5 frequency has decreased before the boundary. And so another proxy we have is the global methane concentrations, and you can see that all throughout the previous oscillations, they don't match up between hemispheres. The top one is Greenland in the Northern Hemisphere. The bottom one is Antarctica. They don't strongly correlate over both hemispheres. But at the Younger Dryas event, that massive methane spike occurs globally. It's the only one on the record that does. And there's other strange atmospheric effects, like a massive injection of carbon-14 into the atmosphere, and a large freshwater flux into the oceans too. And as Malcolm was saying, it occurred at the peak of the solar cycle, which you don't expect during a cooling event. Presumably, if there's more solar radiation coming into the system, you would expect the temperatures to rise, but instead they plummet. And yeah, that's really not normal. And that's why the Younger Dryas has been so intensively studied over the years, not just by the Comet Research Group and the Firestone team, but all environmental scientists are really interested in what the hell happened here.
Right.
You go to try and get an ice core and sample an ice core for the Younger Dryas period, and you've got most of it's gone because other people have used it. So the ice cores are there, but they're already been sampled heavily.
Malcolm, you've got involvement in papers, well, all the papers. What do we got moving forward? What's underway right now?
There's some really interesting stuff on the horizon.
Tell us everything you can tell us. Yeah.
Yeah, well, there's a couple of crater samples that are far more convincing, I think, than Perkins. I think Perkins is quite possibly a crater. It's got some issues, but it may be. But we've got some that are just, you just look at them and you say, that's got to be a crater. Then there's some accepted craters that have yet to be fully dated. We'll be looking at those. We'll be getting samples from those. So the crater work is ongoing. And then we've got plans to sample many cores. Dallas is now working with us to sample. This is Dallas Abbott from the Doherty Earth Observatory, is now working with us to sample and do the analysis for a variety of cores from all the oceans. So we're doing a widespread effort, wide geographically spread effort of analyzing cores from various parts of the Earth and seeing just how vast this signature of an event is. We don't know yet that it's in the Pacific or Asia. We've got, from the Channel Islands off California to the South Africa, we've got in southern down to Patagonia in South America. We've got the signatures there. The proxies are there, but we haven't tested Asia, so we don't know. So that's another part of the strategy.
But Malcolm, just in 2 weeks before the summit, that Russian paper came out.
That's true.
And it extended the black mat 1.5 million square kilometers. I think I said miles the other day, but all the way into Central Asia, and the black mat being the signature destruction layer.
Yeah.
Which is not everywhere, but it would be if you had continuously aggrading soils.
Yeah.
But, for instance, you wouldn't have that around here. Or
Yeah, not around here.
Yeah.
I mean, there's plenty of sites in the U.S. and North America that don't have the black map, but they've got the proxies at that level, at a datable level. We just don't have the black map.
Right. Well, I guess Chris Moore's sites with Randy Daniel, they never found the ones on the Tar River in North Carolina. They did not find a break, did they?
I don't think they did.
Yeah.
Yeah.
But certainly Al Goodyear did, and you have found it also in New Jersey, right?
Kind of. Yeah, we think it might be a black mat. It's more like a gray mat.
Yeah.
We're just not sure. But
Yeah.
the proxies are there in abundance.
Yeah. And just to be clear, the black mat is not actually charcoal itself.
No.
The black mat is representative of the changed climate and the wasteland conditions.
Right.
Cold, wet, algal mess that persisted for a... It
Yeah.
sure can, that's
It
right.
often
Particularly
does.
in the European ones.
Right.
Yeah.
Yeah.
But then the nanodiamonds and most of that kind of stuff are found beneath the black mat.
Right. Most of the proxies are at the base of the black mat.
Okay, tell us about your work with the black mat. Go ahead, Gunther.
Okay, I just have a comment about the spreading and the homogeneity of some of these proxies. If you remember, like a Chernobyl, where there was a lot of fallout, you could trace that there are anomalies of the radioactive material compared to the complete absence. And we are dealing with a similar thing. We are dealing with the atmospherical transportation of these proxies to various locations where they are deposited. And so that could very well explain why we see somewhere, for example, much more enhancement of the proxies in some locations, and some of them would have an absence of them.
Hey, Mark, see if you can find that Perkins paper just so we can show some of that eye candy, and we'll start wrapping up here in a minute unless the audience has anything. Go ahead, Joanne.
Okay, so I've worked on black mats in the Netherlands and Belgium, and they call it the Oslo horizon in those two countries. They call it a soil in Germany, and there's also it's characterized. It exists in Poland as well, and as you said, Russia is finding it. And Gunter and I were looking at Czechoslovakia. There's a site there, and I was thinking it would be really good if we could pull all those together in a study and quantify what is the characteristics, which most likely they've done that in the paper, but most likely they also have not methodically tested for platinum. So that would be a good thing to do to show that is a related regional signal, over Europe. So,
Well, they seem to be very qualified scientists. A couple of them, I think, were members of the National, Russian Academy of Sciences or whatnot. And,
well, Gunter knows, the author of that.
and those are the most welcome
Czech
papers.
paper.
That's where, nobody in the Comet Research Group, to my knowledge, knows anyone that was on that paper. And it doesn't do your career any good to go publish on this. So they must have found it compelling that they, had the intellectual courage to bring it forth. And now everybody will say they're a member of the Comet Research Group, because that's what happens. You can't just be an independent scientist that says, they now join the club, I suppose, even though we've never exchanged an email with them. But those are the most welcome papers that just pop up when somebody, a scientist with the proper sites goes out and says, well, I'm going to take a look at this, and holy shit, I found it. And that happened in South Africa. The paleontologist down there had a well-dated Wunder crater, coincidentally a crater, it's not actually a meteorite crater, but it's called the Wunder crater, and they knew the stratigraphy really well, and they had all the instrumentation, and he went out and looked at it, and he had 1,000 times the elevation of platinum at 13,000 years ago. Every time somebody looks, they find it. Go ahead, Malcolm.
So far, what I found at those 4 sites is there's a lot of soot, there's a lot of charcoal, there's wood with like silica melt on it, there's fused quartz or sand grains, there's melt glass, there's sponge spicules. So it's at all 4 sites. Mm-hmm. So to me, it looks like a thermal pulse and an event horizon. So to me, we should be focusing more on that. And there was a paper written by Bas van Hale in 2008, I believe, where he was saying, well, we don't have to have a comet to ignite, all of this. It could have just been a drought and then lightning or people. And I thought, but it's over such a large area. Mm-hmm. So, but he's not really going to stick his neck out and say, yes, it was extraterrestrial impact, unless he's got something that can back that up for sure.
Okay, last chance for any questions. Tony Zamora. And you got some there. Okay.
I think Malcolm wanted to say something real quick.
Yeah, I
Oh,
was
excuse
going to
me,
say
Malcolm.
that one of the things that are often cited is that the lack of irreproducibility of the proxies, and there have been a number of papers, a number of good studies. The Andronikovs, in particular from University of Arizona, have replicated the results at some of the same sites we've worked, and found the same proxies, but for whatever reason, no one wants to go near this. The effects of the backlash of the orthodox stories have soured the waters, so that people don't want to push, don't want to come back or dispute, don't want to debate it.
Yeah, I'd rather we're willfully ignorant.
Yeah. So,
go ahead, Tony.
Yes, I was wondering if there are any plans of bringing the Carolina bays as proxies for the Younger Dryas, and because now that I have been able to show that they are perfect ellipses within 1.5%, it can be excluded that they were created by wind and water or thermokarst, and also the fact that the impact energy required to form them is about 8 megatons per square kilometer, offers some solutions for the objection that they could not have created the megafaunal extinction, or at least triggered it. And so, and it also offers the possibility of creating a physics-based model, which some critics of the Younger Dryas Impact Hypothesis have been screaming for, because you can use the secondary impacts as to calculate the energy of the primary impact. So, I don't know where this is going.
Malcolm, I'm kind of interested. You don't believe that you were fascinated when I first met you in the Carolina Bays. You did detailed investigations of it.
Yeah.
You determined for yourself and that it was unrelated to the Younger Dryas event. Tell us a little about your take on Carolina Bays, and then I've got a follow-up question.
First off, I think it's a problem that it will take a long time to solve, and I don't have the energy or the time to spend with it. But I've also was heavily influenced by paraglaciologist Mark Dimitrov and Chris Moore, and they've both studied them far more than I have, and they're very, very much into the the idea that they were created by fluvial and aeolian processes that were active during the climate of the Younger Dryas or previous, during the LGM. So to me, proving the Younger Dryas, I think they're great time capsules for whatever's going on in the environment. They'll end up in those features, but determining whether or not they were a result of an impact, I think whatever they originally looked like, they've evolved. So I'm just saying I don't know what they are, and I don't.
Are you intrigued by Antonio's discovery a few years back, or insight, that the bays in the Carolinas, those that, when they're kind of at their most perfect and they become more deformed as you move north or south, that those in the Carolinas, and there are tens of thousands of them, are perfect ellipses? Why does wind conspire to draw such a perfectly geometric shape?
Well, if you look at any seasonal cycle, you'll see that wind tends to have a preferred direction, and that can set up a case where water can be induced to circulate.
I'd like to see somebody model it, though. I mean, let's go ahead. If Kakrowski, they still go back and refer to the 77 study. I think it was unpeer-reviewed, funded by NASA, and the guy, I don't know, there's some other knock against it, but it ended the Carolina Bay debate for about 20 years because he took a sandbox and a puddle of water and put a fan on it, and it blew it into...
Importantly, he took a sandbox and made a hole and then filled it with water.
Yeah, then filled it with water.
But where'd the hole come from?
So why can't we do some of that hydrocode? I never know what that means, but it sounds appropriate. Hydrocode modeling and see what happens when you blow the Atlantic coastal plain with that, grain size and whatnot, and you interacted with water. Does that result in ellipses? Does it result in anything that looks like a bay?
But he started with the hole with no question of where the hole came from.
Well, I think Malcolm's yet to explain where the holes came from.
Yeah.
I mean, and Chris.
I'm not going there.
Yeah, okay. You hung your Carolina Bay hat up, and you're not putting it all back
That's
on,
right.
Okay.
It's too
Go
big a
ahead,
problem.
Joanne.
Well, it seems to me that if those all occurred at the beginning of the Younger Dryas, if you could go and core those lakes and date them, then they should have an origin time of around 13,000.
Yeah, but it's all over the map. And if it was, I mean, it's just the dating.
From the
There's
center.
no age depth model to it, which suggests to me that it's a tumbled mass of stuff during a catastrophe of some sort. I don't really think, I'm not hung up on the YD, but I'm convinced that they were all created at the same time.
Yeah.
And the mainstream says that it was created during 3 or 4 different episodes, separated by tens of thousands of years. And I believe if that were the case, you would see classes of them. You'd be able to see, okay, this is class 1 from 32,000 to 25,000 years ago. That bay formation period, here's one from the next one, here's one from the next one. I don't think that the old ones would then be reoriented or the wind would come back in exactly the same direction. It just doesn't add up to me.
Yeah, and I have to say that in order to have secondary ejecta analysis, you've got to have a site to begin with to see where it derived from, where whatever hit the Earth in those patterns, what their source was.
Right.
And the other thing is, I was going to say, the one that I looked at was 28,000 years. The dating that was done on it was a big bay, 2 kilometer long ellipse. And then the other argument, I think, is that the mere fact that these are ellipses and a variety of there's some variation in the ellipses and some variety in their orientation suggests to me that they're not convincing as impact features. So the mere ellipticity of the feature doesn't persuade me that, which I'm not saying is not.
No. I'm not saying it's persuasive of an impact. I think that it
To me, it's an evolution.
causes me to question whether winds alone just happen to form ellipses.
Yeah.
When blown, and I think you just see a lot more of it around the world. Okay, let's say Stephanie said there's some questions from the live stream, if I understood our sign language correctly. Okay. Or the on demand. We need to rebrand it because people.
All right. Where would the air suspended platinum come from for proxies to be produced by lightning? Yeah, that is a good question, and it probably.
What's the question again? I didn't quite
So,
get it.
if the Younger Dryas was a solar event rather than an impact, how would the platinum come about? Is basically his question.
It's a good question. I
Yeah.
would say that's why,
Yeah.
another reason I believe it wasn't the sun,
Yeah.
although I'm much more fearful of the sun than I am comets. Yeah. Yeah. I'm not downgrading that catastrophic
No.
scenario.
And both events will produce lightning.
Yeah.
So it would be hard to tell them apart.
Well, Malcolm, I want to put you together with Bob Grenier. Have you heard that name, fellow walking around? Bob, in his studies of plasma, has found that plasma is creating crenulated iron spherules. Were you aware of that? He does whole
Dimly,
live
yeah.
streams. And I'd like you two to maybe talk, if you could, at the speakers dinner and just see if there could be some cross-pollination, because he's a whole nother field of study and a buddy of mine, and then he goes nuts about 2 years ago and says, they're creating crenulated iron spherules. And here I am on the other side of kind of my interest. I mean, that's one of the chief proxies. So maybe plasma interactions can create spherules. Maybe it was a sun event, and somehow that results in spherules.
Yeah.
But
Well, you still have to have the other proxies as well. The large fragments of milk glass that we find.
yeah,
Largest I've ever seen are, of course, at Tal El-Hammam. But yeah, I mean, the industrial processes produce microspherules in abundance. And that's one of the things, the contaminants we got to watch out for, is we don't mistake it,
Right.
Those that are anthropogenic versus those that are natural.
Stephanie, we got anything else?
Does anyone on the panel have any information about Sumerian tablets and evidence that the Anunnaki had advanced knowledge of the Younger Dryas events?
Wrong panel.
Yeah, pretty much.
Yeah, we
Steve, you want to take that? Steve, what's your take on the Anunnaki? I'm serious, just for fun. What's your take on the Anunnaki?
The Anunnaki.
Or do you have an opinion? Okay.
Well, we started with, what's his name, Ignatius Donnelly,
That's
casting
right.
this whole theory.
Yeah.
Being casted, this whole originator of the Younger Dryas impact,
Yep.
or an impact in the past, the antediluvian past. That's the source of it. We were pseudoscience then, and it looks like we're being cast as pseudoscience now.
Yeah.
So,
Yeah.
full cycle.
Well, you certainly don't seem to be a pseudoscientist,
I hope
Malcolm.
not.
You seem to be a real rocket scientist. Okay, anything else? And then we'll wrap it
That
up.
seems to be it for the live chat. Yeah, that seems to be it.
We good?
I have the Perkins stuff up on the screen if you want to touch on that briefly.
Yeah. Well, maybe just show some of those materials that were found. And actually, Malcolm, you cast a little shade on Perkins.
Well, there's a lot. It's got a very complex history. What I find most interesting about Perkins is that the story of that depression goes back.
Go ahead, start again. Yeah.
Okay. It's a complex site, very complex site. And there's a lot of possibilities, distractors or detractors from the possibility of it being an impact. But the most intriguing thing that I see, besides the evidence that's there, and it's abundant, the source of the abundance is what worries me, because it's got this complex history of human interaction.
Mm-hmm.
But going back to the original site, before there was any industrial activity, before there was any major human activity, when the original site was homesteaded, there was a pit there that was anomalous to the locals. And they said, what could that be? And they thought it was, and this is, of course, gas country, right? This is a petroleum and natural gas country. They were of the opinion that it was a natural gas blowout of some sort. But it was that anomalous that they took notice of this thing. So it wasn't just a common hole in the ground.
Right.
It was something odd about it.
Well, the largest melt product that the Comet Research Group had ever published would be what? A couple of millimeters kind of thing in the past? Yeah,
I'd say that's
right?
accurate, sure.
Okay, look at that thing at the top left. It's
Yeah.
sitting in the scoop of a front loader.
Yeah.
I mean, that's some big tektites there. Yeah.
No doubt. Yeah.
Very, very strange stuff. And there are probably, several thousand locations on Earth, if we know what we're looking for, and somebody's looking, that you can expect to find these places. And I think that'll be interesting as that unfolds over the years. And the Comet Research Group has another couple of sites in the queue to be published that are just as convincing as this one or more so.
I think so. Yeah.
Yeah.
I would judge them.
Well, we
to
look
be.
forward to that. Okay, one last look at the audience.
Just quickly, Malcolm, I think if it was a natural gas seep that caught fire, for example, would you expect to see these carbon spherules, like the copal spherules and
Well,
stuff?
I'm not saying that they're due to that.
Yeah.
You know, what I'm saying is that the history of the site is complex enough that they could have other sources that were superimposed on the site that we find.
Because, I mean,
there's some evidence that they're not, but there's conflicting evidence that they might be other more modern sources.
because to me, the grid on the left, the top right of that looks like a pretty compelling piece of trinitite to me. Like, that looks a lot like trinitite.
I'm sorry, which one is that?
One sec.
Whoa, top right?
This one.
Oh, okay, got it. Yeah, that's a good one. And the one on the lower left, too.
Yeah.
Well, this won't satisfy some of the disinterested who are surely not watching in, but a lot of people who are disinterested ask, well, why does it matter? Well, first of all, people kind of, and I'm kind of close with this, keep in mind that the comet and the dinosaurs, is taught in schools, is considered significant. It's part of our past. It's things we should know about our past, right? That was 65 million years ago. Okay, to me, that might as well be on another planet.
Yeah,
it's just
essentially was.
Yeah, something 13,000 years ago is more or less 1/5000th of that timeline. So if you did a timeline from here to California and put the dinosaur killer, at the other end of I-40 in Barstow, California, this would be, at the IHOP on High Point Road.
Right.
It's 1/5000th. It's
Yeah.
less than a mile away in time. And the other one's in California. That's recent. But then what happened after that? And Dr. Andrew Moore, who's a part of the Comet Research Group, and you can look him up, he discovered the origin of agriculture in 1972, and he's credited very, very widely with that, and that's at Abu Huraira, another Middle Eastern site, that he'd studied for 50 or 60 years, and he was approached by the Comet Research Group and said, hey, can we study some of your materials that you've stored from the site? And y'all returned with the results, and he was an intellectually honest individual and knew good science when he saw it. And he said, well, my Lord, I've been wrong about this cooking hearth all these years. It was actually a burn layer. And he published a fantastic paper. It probably couldn't have done that 10 or 15 years ago during his active career, but he's been head, this one bugs me, they call it pseudo-archaeology. He was head of the American Academy of
Archaeological
Institute of Archaeology. He was president of the largest archaeological society in the world, and they call us pseudo-archaeologists? I mean, their main guy, and he was a recent past president. It was like 2 presidents ago. And their main guy says his main site is a location of the catastrophe. But I asked Dr. Moore once, I said, well, Dr. Moore, if that was the catastrophe layer, and then you find other things that indicate agriculture and domestication of animals and penning of animals immediately afterwards, I said, how long did that take in your mind? Was that geological time, archaeological time, whatever? He said, immediately. I said, what do you mean immediately? He said, when they came home, they weren't there that day. And he did. I didn't know that. He said there are no human bones there. You've got the habitation, you got, all the other things. They knew there were people there, but there was no people there that day. And then archaeologically, he sees no timeline. Now, surely there was something. It wasn't like they came back and planted the first wheat the first day, but from a archaeological timeline sense, he meant it was immediately, which is a great mystery. Why in the world, when you're traumatized like that, do you then say, let's tie up the goat and let's start a garden? I mean, why do you do that? Any thoughts on that? But what that gets to, and it's hyperbole, may seem hyperbole.
I think it's the end of a long process. I think that's
why we're the textile-covered ape with the black mirror. It's why we're here, is because of that catastrophe.
Yeah.
It affected us in some way that sent us on a technological path. And that's why we should know about it, damn it. It's our origin story. So with that, we will turn to Günter Kletschka.
I just have one more comment to someone who was online and who was asking for the proxy evidence that would be generated from outside, either from the sun or cosmic radiation. There is such a proxies, and it's in the form of C14, because C14 is being recorded in the trees, both on Northern and Southern Hemisphere. And so there are records that separate the two, and so you can see that there is always like a Northern Hemisphere has an enhancement of the C14 isotope compared to the Southern Hemisphere, but there were periods in the last 50,000 years where this dichotomy was disrupted by some event. And so this would be a way how you could identify that there was something happening with the solar wind or with the galactic wind.
Thank you very much, Gunther. That's interesting. But there was a C14 spike at the YD too, right? Yeah.
Yeah. And those C14 spikes have recently been called Miyake events, I believe.
Mm-hmm.
And so when they're looking through the tree ring data and they see a massive spike, it's called a Miyake event, and there was one of those at 14,600. So
Wow.
Quite a large one. So.
Okay. Last round for questions, comments, observations. Okay, well, that will conclude, at least as far as I'm involved, the formal programming of Cosmic Summit 2025. Thank you very much, scientists, and live stream, and our audience here in Greensboro. Thank you.
Thank you, George.
Can I drive straight to the beach right now, or do I have to go get those T-shirts?
T-shirts. That's why I came.